Hello friends, today we are learning the excitation table of all the flip-flops. So basically, flip-flop is the sequential circuit which is not a combinational circuit. So we cannot predict the inputs from the truth table itself. That's why we require the excitation table. So first we will see the excitation table for T flip-flop. Here is the truth table of the T flip-flop. In the T flip-flop, two inputs are given, 0 and 1. Qt plus 1 is the next state and Qt is the previous state. So when the input t is equal to 0, we get the output as the next state, which is the previous state, that is Qt. And when the t is 1, we get the output is the complement of the previous state. So the operation performed when t is 0 is the no change, means whatever the previous state, we get the same output. But when t is 1, we get the complement of the flip-flop, so the toggling of the flip-flop. Using this truth table, we can generate the excitation equation here, the characteristic equation, which is to generate the next states which is equal to t complement, that is when t is 0, t complement into the previous state, that is qt, plus t into the complement of the previous state. So it is t XOR qt. So this is the equation of the t flip-flop. Using this truth table, we can generate the transition table. So in the transition table, instead of writing the Qt and Qt bar, we are writing the value for Qt and Qt bar. So first, when t is 0, Qt is either 0 or 1. Same way, when t is 1, Q is either 0 or 1. So Q plus means the next state. So when it is 0, 0, when it is 0, we get the value of Qt and the value of Q is 0 and that's why it is 0. The next state is 0. When the t is 0, we get the previous state as it is and the value of the previous state is 1, so we will get 1. Same way, when t is 1, we get the complement of the previous state. So if the previous state is 0, we get the output 1. And when the previous state is 1, the output is 0. Using this truth table, we are finding out the excitation table. So difference between the transition table and excitation table is, in the transition table, using T and the previous state Q, we generating the next state. But in the excitation table, using the Q, that is the current state, and Q plus, that is the next state, by predicting next state, what will be the value of the T. So when the Q and Q plus, that is the current state and the next state, is Q 0, 0, we will see in the transition table. So when Q is 0, Q plus is 0, the T value of T is 0. So we are writing it 0. Same way, when the T is when the Q is 0 and Q plus is 1, so the third row is here. So the value of T is 1. So 1 is here. Same way, when the value of Q is 1 and Q plus is 0, so 1, 0, the value of T is 1. So we are writing here 1. And when it is 1, 1, so this is a 1, 1 and the value of T is 0. So here it is 0. So in this way, we are finding out the excitation table of the T flip-flop. Now we'll see the excitation table of T flip-flop. Again, here is the truth table of the D flip-flop. So when D is 0, we get output is 0. When D is 1, we get the output is 1. So the operation is like, when D is 0, the reset operation will be there. And when D is 1, the set operation will be there. And the equation is Q T plus 1 equal to D. Whatever the value of D, that same will be reflected into the output. Now we will generate the transition table. So when the D is 0, whatever be the previous state, doesn't matter, we get the output 0. Same way, when D is 1, Whatever be the value of the previous state, we get the output 1. So now using this transition table, we can finding out the excitation table. Again, I already told you in the excitation table, we are finding out the value of D. So when Q and Q plus plus, we have a combination 0, 0. The output is 0 using this transition table. When it is 0, 1, again third row, the output of D is 1 and that's why 1 is written here. When the input is 1, 0 for the Q and Q plus, when it is 1, 0, the output of D is 0 and that's why 0 is written here. And when Q and Q plus is 1, 1, here it is 1, 1, the value of D is 1. So same sequence will be generated 0, 0, 0, 0, 1, 1, 1, 0, 0 and 1, 1, 1. So this is the excitation table of D flip-flop. Now we will finding out the excitation table of JK flip-flop. So here it is the truth table of the JK flip-flop. In the JK flip-flop, the input is 0, 0, we'll get the QT, that is the previous state. So no change in the operation. When the value of JK is 0, 1, we get the output 0, that is the reset condition. When the JK value is 1, 0, we get 1, that is the set condition. When it is 1, 1, we get the complement of the previous state and that's why it is the toggle of flip-flop, toggle of the previous state. Using this truth table, now we are generating the transition table. So in the transition table, first JK is 0, 0. So we are writing here 0, 0. When JK is 0, 0, the previous state is either 0 or 1. So if the JK is 0, 0, whatever be the value of previous state, that will be your output. So when 0, 0, the previous state is 0, so output is 0. Again 0, 0, the previous state is 1, so output is 1. This is the first line. This is the first line. Okay. Now, when the value of 0 and 1 is there, the output is 0. Whatever be the previous state, output is 0. So the value of J and K is 0, 1, 0, 1 and the previous state is either 0 or 1. So whatever be the value of previous state, output is 0 as per the truth table. So if it is 0, 1, you will get 0. Same way, it is 0, 1, you will get 0. Okay. Now, next thing is, when your output is 1, 0, when your output is 1, 0, your output is, when your input is 1, 0, your output is 1. Whatever be the previous condition, your output is 1. So here the value of J and K is 1, 0, 1, 0. Whatever be the value of previous state, that is 0, 1, your output is 1, 1 here. Okay. So here it is written 1, 1. Now we'll see the last state. So in the last state, the input is 1, 1. So when the input is 1, 1, the output is complement of the previous state. So in this scenario, the previous state is important. So here, when the output is 1, 1, the previous state is 0. So the complement of this 0 is 1. Same way, when the input is 1, 1, the previous state is 1. So complement of the previous is 0. So this is the transition table of JK flip-flop. Now using this transition table, we will find out what is the excitation table. So now using this, we are generating the excitation table. Okay. So as I already told you, in the excitation table, we are considering the value of the previous state and current state and finding out the value of J and K. Okay. So first, when the value of Q is 0 and the Q plus, that is the next state, is 0, means this first row. So at that time, where is Q and Q plus? Plus is 0. So here it is 0 and here it is 0. So this is 0 and this is 0. Now if you notice, when it is 0 0, the J and K is 0 0 and 0 1. So the value of J is not changing. So we are writing here 0, that, and the value of K is either 0 or 1. So when it is two states, 0 or 1, so we are writing here don't care. X means don't care whether it is 0 or 1. So when J is 0 and K is 0 or 1, you will get 0 0 as an output. That's why when it is 0 0 in the excitation table, you will get 0, don't care. Now we will see for the next condition. Okay, so next condition is 0 1. So when your input, when your output is 0 1, Q is 0, previous state is 0 and the current state is 1. So 0 1, we have to find out where is 0 1. So here it is 0 1. It is 0 1. Now we will check what is the value of J and K at that position. So this is the value of J and K. So if you notice, the value of J is 1 and the value of K is 0 or 1. So we are writing here the value of J is 1, which is constant, and the value of K is 0 or 1, and that's why we are writing here don't care. Now we will finding out for third. The value of third is 1 0. For 1 0 we have to finding out. So 1 0 is here, again 1 0 is here. So at the 1 0 position, what is the value of J and K? So the value of J is 0 1 and the value of J is 1 1. So now if you notice, the value of J is 0 or 1 and the value of K is 1 1 constant. So that's why we are writing here, X as it is 0 1 and 1 which is constant, and that's why we are writing here 1. Now we will see the last row. In the last row, the value of Q and Q plus is 1 1. So the value of Q and Q plus is 1 1 here. So where is 1 1 we will see. So here it is 1 1 and here it is 1 1. So if you check, the value of JK is here 0 0 and here it is 1 0. So first we will check the value of J. So the value of J is 0 and 1. 0 1. So we are writing here cross, and the value of K is 0 0. That's why we are writing here 0 only. So in this way, using the transition table, you have to generate the excitation table. Remember, in the excitation table, wherever you are writing X, it means it is the don't care condition. Don't care condition means either you can consider it as a 0 or 1, doesn't mean. So this is the excitation table of JK flip-flop. Now we'll see our last flip-flop, that is the SR flip-flop, which is very much similar to the JK flip-flop. So we will see here the truth table of SR flip-flop first. So when it is 0 0, the output is the previous state as it is, so operation is no change. When it is 0 1, output is 0, that is the reset operation. When it is 1 0, output is 1, that is the set operation. And when it is 1 1, it is undefined, means it is invalid. So the equation is R bar Qt plus S. Whatever the value of S, that will be the output. So if S is 1, the output is 1. If the value of R is depend on the value of Qt. Okay, so this is the equation. Using this truth table, we will generate the excitation table. So when it is 0, 0, when it is 0, 0, the value of Q is 0 or 1. So the output is that same value. So the output is 0, 1. When the input SR is 0, 1, output is 0 always. So that's why we are writing here 0. Whatever be the previous state doesn't matter. We are writing 0. Same way, when the value of S and R is 1, 0, the output is 1. So we are writing here 1. And the last state, when the 1, 1, it is undefined. So we are writing undefined. There will be no change. Now using this, we are finding out, using this transition table, we are finding out the excitation table. So first state, the value of Q and Q bar is 0, 0. So the value is 0, 0 here and here, 0 and 0. At that position, the value of SR is 0 and 0, 1. So S is constant, that is 0. So we are writing here 0. And R is 0 or 1. So that's why we are writing cross. That is don't care. Now we will check the next condition. Our next condition is 0, 1. So when it is 0, 1, this is the condition. And okay, this is the condition. Only one condition we have. So when it is 0, 1, it is 1, 0. So we are just straight away right here 1, 0. There will be no any other condition. Now we will check for the third row. So third row is 1, 0. When the value of Q and Q bar is 1, 0. So 1, 0 is written it here. And there will be only one row because here it is undefined. So the value of Q is 1 and Q plus is 0. So the value of S and R is 0, 1. So we are straight away right here 0, 1. There will be no change in it. Now next is last condition is 1, 1. So we will find out where is 1, 1. So here it is 1, 1 for Q and Q plus bar Q plus, and here it is 1, 1. So when it is 1, 1, the value of S and R is this. As you notice, the value of S is 0 or 1. So we are writing here cross, and the value of R is constant, that is 0. So we are writing 0 here. So this is the excitation table of SR flip-flop. So using transition table, you can finding out the excitation table. Now this is the master excitation of all the flip-flop, you can say. So as you know, excitation table is used to finding out the inputs when you know the output, or you know the sequence of the output. So outputs means Qt and Qt plus 1. Qt means your previous state and Qt plus 1 means your current state, or you can say like that, Qt is your current state and Qt plus is your next state, which will be the generating. So using this, when it is 0, 0, what will be the value of SR, what will be the value of JK, and what will be the value of D and T flip-flop. So this master table will help you to finding out the inputs when you generating your circuits. So basically this excitation table will help you to finding out the counters. When you design the circuit for the counters, synchronous counters or asynchronous counter, it will definitely help you. Or when you use the sequence generator, then also you will use it the excitation table. I hope you understood the concept of excitation table through the truth table and through the transition table. Thank you so much.